Hello! In this video I will show you how to use real-time audio data from your microphone inside of Blender. So, if you never used Blender and Python together before, or even if you never did any programming in your life, don't be scared, because I think Blender together with Python is one of the more accessible and also very rewarding ways to get started. So the first thing we want to do is switch over to the scripting tab. And another very important thing is to toggle system console. So yeah, we go to Window, toggle system console. This gives us this console window. And if Python prints anything, it will go here. So if we have errors in our script, we see it here. If we want to print variables for debugging, we can see it here. So yeah, crucial. You can see I already have a small script here, but we will rewrite it now together. So yes, you have to move the mouse cursor in the window to do editing. So yeah, in my scene I just have this cube, and that's the default cube, that's it. And I created my new script file. So if you do this, usually you just click this new text button. And then in any script, the first thing you want to do is type import bpy. So this will give us access to the whole Blender API. And yeah, obviously since our Python script will interact with Blender, we need this. And then the second thing, and this is awesome. This is why I love Python inside of Blender so much. So let's say we want a script that manipulates the size of our cube. We can just open the panel to see all of the properties of our cube. Here's the scale. Let me reset it to 1. And if I want to manipulate the X scale inside of Python, I right click, and here you see copy data path and copy full data path. I'm going with copy full data path. So this gives me bpy, which is what we imported, .data.objects. So because our cube is an object, then we see it is the name of the cube, and then we access the scale. It has here a little 0 inside of brackets. We will get to that in a moment. So we get our scale, and now we can just say equals whatever we want. Let's go with 3 and run our script, and you can see the cube just got bigger. And that's all there is to it. Also here in the inspector, you can see, oh yes, scale is 3 now. So if we run our script again, but let's put 2 this time, it gets smaller. That's all. And about this little 0 here, that's just so because we have 3 dimensions, so there's 3 scaling parameters. And so if I instead of 0 put 1, it will be the Y scale, and if I put 2, it will be the Z scale. Let's get to why there is the option of copying data path. So this option here, instead of copying full data path. So copy data path. Let's copy it, let's paste. It gives us just the parameter of the object, not the reference to the object. So the idea here is to define a variable that is then the reference to the object. Let me just cut this out here. So bpy.data.objects and then cube would be the reference to our cube. And then we would be able to just write cube.scale and set it directly like this. Let's put some variable that is different so we can see the change happen. And I run it and you see same thing, but now it's a bit easier to read, especially if we maybe also want to adjust the location. Also same thing here with location, but of course you can just copy the data path. So I want my location to be 3, and this will be the Y location. And yes, you see, it moves to 3 in the Y-axis. Awesome. So now, since we want to do some real-time manipulation, so we use the microphone input and then we continuously the scene will update depending on what the microphone input is at that moment. So we cannot just run our script and update it once. We want the script to update basically every frame. The way to do this is quite simple. So again, I have a pre-written script, but let's just go over it together. The important part is here at the bottom. So yes, especially this line here. So it says bpy.app.handlers, and then we have a frame change pre, and we add something. We put this animation function that I defined up here. To make it short, this will mean every time before the next frame is initiated, it will run this function that we link here. So here you can see I wrote again about the cube, but this time adjusting the rotation, and I'm adding some value to it. So for those of you who are not into coding, plus equals just means I want the result of the variable to be the same plus what is at the end here. So it will be the rotation we had before plus 0.2 basically. And if we run this, nothing happens because it depends on the frame of the scene actually changing. And this is not happening. So if I hit play in my Blender scene, now you can see it just increases the rotation every frame by this value. So if I put a lower value and just start it again, rotation slows down. Maybe if I go crazy and put some higher value, wow, okay, rotating so fast, so wow, so rotation. Then also I want to point out this line quickly. So the idea here is it just says the same like handlers frame change pre, but then it says dot clear. So the idea is if we run this script, and because of course we make changes, so you already saw me do this, I just type some other value and rerun the script while everything is still live. Then we don't want both things to happen. So let me just, what if I remove this? So I put 0.1 and run it again, but you see it gets faster because it doesn't remove the animation function we put before. It just runs the animation function and also the other animation function and also the other animation function. So it just keeps adding these animation functions on top if we don't clear it. So that's why we have this line here, just so that when we run it, it actually removes all the older frame change handlers that we appended before. But this video is supposed to be about sound and microphone data. So let's get to this. And the first thing we have to do is install, I think they call it a Python module. And this is could be very easy, but in Blender it's slightly more complicated. But yeah, I show you the code and you can just copy this code like I did. So first we need to import pip. This is basically what Python uses to install modules. And then we import sys, for short for system. From system, we can get the execution prefix, which is the path where this Python script is running. So this is to make sure that our library that we get is installed into the location where the script is running instead of our global Python libraries directory, since Blender's installation of Python is separate from that. And then down here, so we just use this target attribute and assign our execution prefix together with then the actual path where the packages go. And of course here we need to write the name of the module we want to install. So in this case it's Pi Audio, so I just write Pi Audio here. Now if I run this and switch over to my console, you can see a lot of red text, and basically here in the beginning you can see it says permission error. This might also happen to you. So we want to open Blender by right clicking it and then saying run as administrator. Yes. And I just open the project again. Make sure I have my system console toggled. Now, when I run the script, you can see successfully installed Pi Audio. Now with Pi Audio installed, let's finally get to reading out some microphone data and doing some movements in Blender with that data. So there's just some standards based on Pi Audio. So on top, I'm importing again bpi, like always. I'm also importing NumPy. You don't have to install NumPy. Usually, it is pre-installed. And then I'm importing Pi Audio, which is what we just installed. And then here, defining some variables. Let's get to them in a minute. And to actually do anything with Pi Audio, first, yes, we need to call this Pi Audio function and assign it to a variable so we can later access it. And then we open a stream. So calling PA, so Pi Audio, what we opened earlier, what we defined earlier. And yes, open it with all the variables from top. So format is, well, I mean, it says PA int 16, so it's Pi Audio int integer, just being full numbers. Just use this, it's the right one. Channels, so channels will be if your microphone is stereo or mono. And in this case, if you have stereo, you put a 1. So it is 2 channels but you put a 1 because it starts counting by 0. So 0 would be one channel, and 1 is two channels. Good, then we have the rate. This is basically the sampling rate. So how many times per second is the position of our speaker membrane or microphone membrane updated or sampled. Then we write input true, since in fact we want to use this stream to get input data from our microphone. Frames per buffer. So this is basically, since the sampling happens like continuously, or like 44,000 times a second. So it is just putting data points, and with this we are getting like a slice of that. And this is what we are defining here by frames per buffer. It is how many data points do we want to be in that slice. So in this case, it will be 1024 times 2. And then we have the input device index. And with this, you will have to play around. So this is depending on how many microphones or whatever you have connected to your computer. This could be a different value. For me, 1 works. It is trial and error. You will see when it's not working because nothing happens. But it is important to isolate other issues, like to make sure that there is no other reason why it is not working. So test everything, and then when you get to this value, make sure you're only testing if you're getting the right data from the right input. We have our stream set up, and now we actually want to read the data from the stream. So this is what's happening here. So we define a variable named data, and so important part is stream read, and then we read the number of chunk. So this will be like 2024 times 2. But yeah, of course we saved it in the variable chunk. So we will read 2048 data points. So the last 2048 positions that our microphone had, that's what we're getting from this stream. And just basically putting it into a readable array using NumPy. So giving it the data type, how we want to store the data in the array. The problem with this is it is still just like the raw waves. I mean, we can already use it. Let's maybe do this quickly. So now we see. But the important thing is the cube is not just moving up, it's also moving down. Because sound is a wave, and it, like, the values, like the amplitude will be at the same time how far up the wave goes, but also how far down the wave goes. And obviously we don't want this. Like, our goal, or at least my goal, would be if there's a continuous loud sound like I would want the cube to stay at a consistent high position until the sound ends, and then go down to 0 again. The way to achieve this is pretty simple. So here you see I'm assigning a amplitude variable, and for this, so first I'm using NumPy abs, so this means absolute. If we do this just ignores any minus in front of our value. So -1 will just be 1, -5 will just be 5. So we get all positive values back. And then we put it into another function. So this is important, like make sure to numpy apps is one function and it closes here. And then we have numpy average. So our numpy everything after numpy apps is inside another set of braces for the numpy average function. And I mean, as the name suggests, it just takes the average out of all of the values. And then here we define the range. So we want all of the values starting with the index of 0 all the way until chunk. So with chunk being our definition of how many data points we want to read in each buffer. Now, if we use the amplitude value that is defined this way, let me just move our value assignment for the location down here. And now instead of the 6th data point, we use our amp variable. And now, okay, it's a little bit too sensitive, so I will just multiply it by 0.01. And now you can see I make a sound, it goes up. When I stop, it goes down. So yeah, this is already a big improvement over what you get from bake audio to F-curve. Now you just have, I guess, a desired result in the form of a direct loudness response into any parameter of a Blender object. So now to expand on this a little bit more, we can do the demo I showed in the beginning, and instead of only using the average or only one data point out of our audio buffer, we can use all of the values that happened within this time frame and assign them to, like I do it here, individual vertices. So it actually looks like audio waves because it is actually audio waves. So I will just walk you through the script and maybe quickly pause. Wow, looks so cool. Yeah, just pause this animation quickly while I explain so it's not too distracting. So we are still doing the same thing. We are getting the data. And then here is where it changes. So we define two variables, just vertices and edges. Let's ignore maybe edges for now. Quickly commented out the part about the edges. So now you can see it's only points, and I think it's a little bit simpler to explain. So yes, we create our variable. Pause you again. We create our variable for the vertices. It's just an empty array. And then we loop through. So the way we do it here, the x value would be our index. So we have this 2000 values that we go through, and x would be the number of, like, this is the first one, this is the second one, this is the third one. So just at what point in our list are we? This pass is also not needed, it was just for debugging. And then we say, okay, we have this empty vertices array, and so it will be a list of vertices, and we want to add something to it. And what we add will be the position of a vertice. So we're using x, since x is so the number in our list, and I'm just multiplying it by 0.01 do make it smaller, because otherwise, so it would be like one Blender unit, which would be, so every point would be one Blender unit apart, which is obviously a little bit far. I can just maybe demonstrate it quickly here. So if I putting 1, running it again, now they're one Blender unit apart. So that's how this works. Putting it back to 0.01, and now they are packed nicely and densely. And then for the y variable, so you can see, okay, we have this braces, so it's like one value, then comma, another value, so the second one would be the y value, but I'm not moving in depth, so I'm just leaving it x0. And then we have the z value. I called my variable y because our I guess our data is only two-dimensional, so it's only x and y values, but we are using the y variable as an input for the z position. And I'm multiplying this with a much smaller value, so it's 0.001. Just this controls how high will our peaks go, and I don't want them to go so high. So if I for example make this even lower, let's make it 0.0001, and I run it again. Now you see I speak at the same volume, but the amplitude we get in our visualization is much lower. Putting it back to what we had. Okay, so we just store, like, append this package of 3 values to our vertices array, like we did before, just getting like this bpay data object cube is our object. Okay, and we are clearing the geometry. So obviously if you're not doing this last part, then it will just be nothing, because we clear the geometry. And then in this last crucial line, what we are doing is, so it does object data, so it sets the object data from pi data, and it takes as inputs vertices, edges, and faces. So in this case we only put vertices, so the other two, so the edges and faces, are just empty arrays. But yes, I already showed it in the beginning. We can also connect the edges. So we connect the vertices to make edges. This is what I'm doing here. So again, I'm looping through the vertices this time. So yeah, we get like all of the vertices from here, and I say, okay, loop through that. So the current vertice from the list that we are looking at will be assigned to vert, and then my index, so the number of the list position where we are at, will be assigned to I. And here I have this little thing to make sure that we are not doing anything for the first vertex in the list. Why is that? So yeah, you can imagine if you have 3 points and you connect them with edges, you only need 2 edges. So point 1 to point 2 and point 2 to point 3. So that makes 2 edges for 3 vertices. So it will be the number of vertices minus 1. So that's why here I'm skipping the first vertex with this if statement. Okay, so after skipping that, I'm doing append in the same way like I did for the vertices, but this time basically what we want to store in the data is for the edge, it needs to know two things. What vertex am I starting at and what vertex am I ending at? And it doesn't care about any position because it gets the position from the vertices that it is assigned to. So here again, we are doing like I-1 for the from position. And we couldn't do that if we start already at the first vertice. So we, then it would be -1. So that's bad. So starting at the second one and then subtracting 1 will get us to 1. And so it goes from 1 and then to 2, basically in this case, because we're not subtracting. And this information, we can just put the edges. We can just put the edges also in here. Running it again, I feel like it's crashing. No, I just did the typo. Did I do a typo? What is the console saying? Okay. So yes, of course, I need to declare my variable before I do any appending or any using of the variable. Now this should work. Running it again, and nice. Now we see it's a nice continuous line since we connected all of the vertices with edges. Of course, there are many more ways to use this. This tutorial is basically just to get you started and get the audio data inside of Blender. And now you can do whatever you want with it. Like, yeah, be creative. Like, you can just, if you put it on an object, you can just use that object as a driver for anything else. So put it into geometry nodes, drive some physics simulation with it. Yeah, I guess the possibilities are really endless. Also, you can go deeper and use something like an FFT, so like a Fourier transform to get frequency data, and then you can make your objects respond to different frequencies, or even like combine that then with animation or material nodes. I mean material nodes also. Just do all of the nodes. So yeah, I think awesome possibilities, and I hope you have fun with